came here tonight to hear about old poop. 14,500-year-old poop, and you've come to hear probably the world's expert at this point on that subject. I'm not sure he wanted to be known as the world's expert on that subject, but you take what you get in archaeology, and Dr. Dennis Jenkins certainly is the world's expert on this at this point. He has been the director of the Northern Great Basin Archaeological Field School for the university for only 29 years. So he knows his stuff. He gave me a little short bio, which absolutely is terribly impressive. He's only written 7 books, 80 chapters, articles, reviews, professional reports, and contributions and reports, and given over 70 papers at professional meetings. Only. So please help me welcome the world's expert on old poop.
Thank you for the applause. I got to tell you, as a speaker, it's one of those things where you go, oh wow, I'm getting paid before I even get started. So I really enjoy that. I want you to know that the University of Oregon Field School works very closely with the Bureau of Land Management and with the Klamath tribes in particular, and the Burns Paiutes. We've actually had some of their students come out and work with us and learn about archaeology, and it's very gratifying to be a part of that. Let's get started. If you've not been to the Summer Lake Basin, this is it. Highway 97 goes, up to Bend. You turn off there just before you get to Lapine and head for Silver Lake, Lakeview area. So we're right down by the California border. This is a shot from about 100,000 feet up. You're in a satellite. You're looking down on it. What's currently called Summer Lake during the Pleistocene was actually a much larger lake. It would have come all the way down through the ZX Lake there and into Lake Abert. So it would have been close to 70 miles long. Just imagine water as far as you can see, hundreds of feet deep. And that would have been the scene at the time that the caves first came to exist. You see the different colored bands. Those represent different elevations, kind of like bathtub rings, if you will. And there are different times when the lake was rising and falling. And people have been studying that, lake. And it's the highest lake stand that actually formed the Paisley Caves. So at that time, this is up on Winter Rim. You're looking down towards 5 Mile Point there in the distance. And the Paisley Caves were formed by wind coming down off of Winter Rim and then blowing up large waves, and they crashed into this volcanic set of cliffs. What happens then is the waves are just full of energy, and they're pulling away at this relatively soft volcanic rock. And so what we have here are soft spots then get eroded away. There are some volcanic or basalt dikes that have been pushed up through this Miocene volcanic tuff, and those dikes are much harder. So the soft rock gets, pulled out very by the wave action, and the caves begin to form. So this is Luther Cressman. He was the first archaeologist to go to the Paisley Caves. There was a gentleman living there who knew Luther, Walter Perry. He lived in Paisley, and he heard from Estelle Johnson that she had been out digging in these caves and had found Pleistocene animals, camels, horses, bison, and she has pictures in an artifact collector's magazine of a complete camel leg bone that has been burned in a fire. We've never found anything like that. She said that she was finding artifacts made out of obsidian with those. And so Luther went in 1937 to look at it, and as soon as he saw the evidence that there were people in the caves before Mount Mazama erupted and formed Crater Lake. He decided that he needed to go there and dig. So he returned in 1938, and again in 1939, and in 1940. In 1939, while he was up at 10 Mile Point working on another rock shelter, his men encountered what appears to have been a house floor. So it was a line of rocks going back to the cave, to the wall of the cave, coming out to a very large boulder, and then forming a U shape. Around the outside of that, they found camel and horse bones in piles. And so there were a few artifacts, but nothing really diagnostic. So we all, would like to see what kind of a spear point was associated with this. Unfortunately, they dug the entire house floor in a single day. It would take me a summer to do that with 8 or 10 students. And the reason is we would be spending so much time recording exactly where every bone came from, where each piece of obsidian was found. I tell my students, if you can see it, I want the exact location. And that's the reason. He published in 1940 that he had proven people were in the northern Great Basin during the Ice Age when those animals lived. It didn't take long, and one of his own compatriots questioned the reliability of his evidence. So that was what the conditions of things in 2002, when I decided, we'll go back there. We don't have a dog in the fight. It's a very simple thing. We'll radiocarbon date, which Luther could not do. We'll radiocarbon date the bones, have them identified to species, and then we'll radiocarbon date artifacts if they're associated with it. And if the two overlap each other, then Luther Cressman was right. And if we can never tie them together, then he probably was wrong. What I didn't know was what effect collecting coprolites was going to have on the entire thing. Now, of course, we collected them. We knew that we could learn about diet. We could learn about health and those kinds of things. But one, I didn't know how many we were going to find. And two, I really didn't have it in mind that we were going to recover DNA at the same time, that we would be able to prove these were human and that then radiocarbon date them. Let's go back to cave number 1. Luther had reported on 3 of the caves that he had done major excavations in. He described number 1 as this beautiful open portico. It was just a great place to live, and the first place that he excavated. We could not find that location. So we didn't know if he started numbering from the north to the south or east to west or what. Well, it turns out it was from the east end of the site up towards the west. And that huge rock behind Suzanne there has fallen since 1940. So eventually we looked at the interior, and I could match that unique interior where number 1 is up there in that square. And I could tell that this was cave number 1, and then the rest of them were sequential. I wanted to know whether or not he had actually dug all the way to bedrock. In other words, did he do an efficient job? So we put in number 1, and we started going down through nice compact sediment. There was an artifact lying right on the surface, a nice big boulder that had been rounded off, clearly out of place. And we went about 60 or 70 centimeters, just about 2 feet. And we were finding cordage made out of sagebrush. We were finding projectile point fragments and scrapers and stuff. And I thought, wow, he's really missed quite a bit of this deposit. And then we found an Olympia beer can and a Snickers wrapper and a Lucky Strike package. And it was pretty clear that people had gotten in there after he had left and had just been digging in the sides. He did not backfill his holes. You just left them open, and so they just trashed the inside of the cave. So I looked around, and we had number 2 up there, and I was looking at that big boulder in the front one day, and a student came up to me, and I was thinking, man alive, that underneath there may be something that people have missed, that the pot hunters didn't get. And I thought, well, what about that? People would be banging their head on the rock if they were digging under there. And this student came up, she said, Dr. Jenkins, if the ground starts moving, what should we do? And I thought, holy smokes, you look around, there's rocks big enough to ruin your day. They're clearly falling out of the ceiling. You tell them to stay in here, they could get hit. You go outside, and there's rocks bigger than the one that you can see right there with the triangle in it, and you could get squished if you ran out and went down the hill. So I said, I don't know, but I'll tell you what. If we had a hole underneath that big rock right there, and it started to move, you would be safe in there because it's already distributed its weight out on the ground, and any rocks falling out of the ceiling would bounce off of it. We might have to dig you out, but you'd be safe. Well, I'll dig that unit. I said, okay. So we were moving. So this is what we found. At that point, we had been kind of disturbed by the fact that we hadn't found undisturbed soil, and then we excavated underneath that big boulder, and it was clear that had deterred people from digging. So what you're looking at is the strata, and each one of those strata, the different colors represent changing environment. So some of it is real coarse, big chunks. Those represent a lot of water bringing gravel off of the cliff up above. And if it happens really in a very rapid method, then there's almost no color. So you can see those gray bands there, and it says very sparse or no cultural materials at all. That's the reason. It happens overnight, and there's nothing in it. Whereas the rest of it, where the darker it is, the more exposed it has been to the wood rats. Now, what people call pack rats live in these caves, and they have forever, for at least 16,000 years, and they are peeing on everything. And so when you go into the cave, you get a whiff of this really acrid, the smell of science. I mean, if you love it, it's great, but the first time it'll kind of knock you on your heels. But that's what that brown is. That represents literally time. The darker it is, the richer the brown is, the longer period of time it has been. And so what you're seeing here, nice flat layers laid down, and that indicates this is undisturbed. If people had already dug it, it would just be all a jumbled mess. Okay, so you'll notice that our time is from the top down. Everything gets younger up near the top, and it's oldest at the bottom. This is one of the one and only hearths or places where people have cooked something, and in this case, it appears to be a pronghorn antelope. This was about 12,500 years ago. Here, down on the lower right-hand side, you can see a piece of basketry that we found. That's, as far as I can tell at this stage, the oldest basketry fragment in the Great Basin, and probably, quite possibly, in America. One of the really interesting things that we found was this and other pine cone or pine nuts. So ponderosa pine, these are big enough that they're worth going after. You take the cones and crack them open or dry them in a fire, and then they open up and you can get them out. This one has been opened by a mouse. I know that because you can see the little nibbling edges. Instead of a human cracking it open, a mouse has stolen this, apparently, from a cache of nuts that apparently the Native Americans had brought in there. We got several of them right around 11,500 to about 12,000 years ago. I at one point had thought that this indicated we actually had ponderosa pines standing on the site, which today, as you've probably seen already, nothing but sagebrush surrounding it for miles, literally. But I had some pollen analysis done from Von Bryant at Texas A&M, and he says that the profile indicates that there were no ponderosa pines on the site, but he thinks this is an artifact that has been brought. So that's still being debated, but we are searching for more evidence in coprolites, hopefully to give us more evidence about that. This is cave number 2, and it's literally almost joined at the back of the cave with cave number 1. As you can see, it's our darkest and deepest cave. There's a large rock right behind this gentleman down below me here that's looking up at me. Right behind him is a huge roof fall. That used to be in that V up at the top. And so it has fallen in the last 2,000 years. I got a coprolite just below the rock, gave us a date of about 2,000 years ago. So at that time, it was very dark in the back, and it would be difficult to do anything if you weren't sitting around the fire. So this is where we excavated all of our numbers. What we did, that roof fall had left a very large boulder leaning against the big one that we see here with the 1369 on it. I took jackhammers, or I didn't. I had, a lot of really hefty college students with jackhammers get on it and break it up. And then that allowed us to conduct our excavations there where you see 6, B, A, B, C, D, and 7. So it was just perfect because before that it had looked like a battlefield in there. I mean, there were rocks and buckets and beer cans and all kinds of stuff. People had clearly been partying in there quite a bit, and we actually found timbers from Luther Cressman's screens and things that he had left in there. So what we found below that very large boulder was this beautiful stratigraphy. Again, I want you to see that we have what we call lamina, or very nice, flat-lying, different colored strata laid down, just like a layer cake. This is absolutely what an archaeologist wants to see. It's beautiful stratigraphy, and at the bottom we have this very dark charcoal lens where people cooked up a bunch of pronghorn antelope. So we published that as a part of our article in 2012. We published in Science and showed these very interesting lamina. Here you can see them in white. Each one of those represents a storm of absolutely intense activity where the wind was blowing really hard and a lot of rain was in it. It blew the rain clear into the cave, up against the wall where it accumulated, and then it began to flow towards the mouth of the cave. Well, that didn't continue on very long, and then it dried. And what it has done is to pick up all the fines, silt, and sand, and leave these little tiny mud lenses. Well, the significance of those are when they are whole, that indicates that they have not been disturbed. And one of the critics of the work at Paisley Caves has always been, oh yeah, well, people were digging in there and they've churned everything up. And so there's no reliability to where you're finding things. And this entire article was designed to demonstrate the evidence that we've got that no, things are in really good condition. These are very fragile mud lenses. They cannot be in place if rodents have been digging through them an awful lot, or if people have been digging looking for artifacts. Oh, back one. There you go. All right, so at the bottom of that, very near the bottom where that hearth was, we encountered what we called the botanical lens. And the reason we called it the botanical lens is it's just a mass of sagebrush. And people have brought in sagebrush, covered the floor. The truth is they were not very cleanly about where they left food scraps. They made probably, they were processing hides of different kinds, certainly pronghorn, a lot of it. You can see these white root-like appearance here on the right-hand side. That's actually the underbelly hair of pronghorns. We have about 8 or 9 of them that have been processed in here. Unfortunately, they were also bringing in all the goo. And I know that because we recovered all of the insects. And dermestid beetles were just thick in this. So basically, if you can think about it, you were sitting on the floor eating your supper, and you would look around, and the floor would appear to move. There would have been bottle flies. We found their remains as well as scorpions and other things. So it was, insects are really great information. I know it's kind of gross to talk about this, especially if you've just finished eating a nice barbecue supper, but it's just wonderful information. And here is a close-up. You can actually see part of one of the pronghorn skulls that's real shiny down here, and then part of a toe bone, as well as, the sagebrush. So once this got really gooey and yucky, they would bring in more sagebrush and lay it down. And that's duplicated in another cave, Gate Cliff Rock Shelter in Nevada, where we have exactly the same thing happening there. Once it got really ugly, they would just cover it over and start anew. So these are the 2 animals that we found the majority of. Pronghorn, we can understand. That's a good package. The rabbits are, it's kind of a strange combination. Why wouldn't you just always go after the pronghorns? Well, I think that it's significant that the Native Americans, the Paiutes, Shoshone, in this area would get together in large groups. And they would go into the valley, and having spotted, a good bunch of pronghorn, they would run them and then run them into a trap and kill them all. Well, that's exactly the way that they handled rabbits also. They would, hundreds of people would get together for a very short period of time and go out, begin a mile away and push the rabbits into long nets, and then be able to thump them with their bunny stick and pile them up and then have a big party. And so I think what we're seeing here is evidence that they're applying the same principles to these 2 different kinds of animals here. One of the questions I had was, well, how do I know for a fact, for a scientific fact, how do I know that those pronghorn hairs were there because people put them there, processing the hides or whatever? Well, I took a look at these, and some of them you can just see are masses of hair, and that one at the bottom has just been sheared off with something incredibly sharp. I mean, no wolf's teeth or a cougar or whatever would ever do that. This has been cut with a very sharp, probably obsidian tool. And in the upper right-hand corner here, you can see, first of all, I draw your attention to the fact that there's blood and mummified flesh attached to this fragment of pronghorn bone here. But there are also notches right at the elbow where, as a hunter, I recognize the fact that that's where I would break off the lower leg and make that cut, and stone tools have cut this. So these are definitely artifacts. This is a very unique form of braiding. You can see the sagebrush cordage that has been braided here. It's just 3 elements. I don't know if you remember when you were probably, first grade or something like that. The teacher would give you, just before Mother's Day, some cordage, and you would make your mom a little keychain or something. They would show you how to do that. and that's exactly what we see here. This has only been found in a couple of places as far as I know, always dated right around 10,200 to 10,400 years, somewhere in there, at Cougar Mountain Cave in Fort Rock, just to the north of the Paisley Caves, and here. So it suggests to me these may be actually the same families occupying two different sites. You look just below that, you just see that absolute mass. It's a little gross when you look at it under the microscope. It's rabbit fur. The hair has been stripped off. There is in there an incredible amount of what looks like urine, looks like poop. It looks like perhaps, blood, fat. I mean, it's under the microscope, it's just incredible. And I just have to remind myself constantly not to apply my civilized mind that knows about germs and understands, that you're probably killing yourself or somebody else, if you're processing food and living on a mat like that. And that's the reason why they would put that sagebrush down to cover it up. I went over to cave number 5 one afternoon and then came back, and one of the students said, "Oh, look at this, we found this." And I took a look at it, and it's just real fine human hair. And I thought, okay, who's salting my site? I can't believe that you would not take what we're doing seriously. And I said, who did this? Who cut their hair? No, it came out of a clump of the bottom of the site. I said, you got to be kidding. This is so fine. It's not black. I expect nice black, what we assume is Native American hair. And this is just real fine and kind of a light color. Well, ultimately, it proved that it was indeed human. We actually sent it to Australia to one of the few specialists in the world, I think, that took a look at it, and she says it's human, and it's just been really eroded away by the urine. So it's immersed in this rat urine, and it made it real light colored and actually damaged it. We tried to get DNA out of it, and unfortunately, we could not. But it's 12,000, almost 600 years old. So I brought it back and I was looking at it. I still wasn't really totally convinced before it went to Australia. And this is what I found on it. That's just one louse egg there. Actually, there were masses of them under the microscope. It makes my head itch just talking about it. But we got an insight into what it was like to live there. There was a lake out there, all right, but it was about a mile away. And the river was about a mile and a half away. And so I don't think that, cleanliness was the major issue inside here. There are coprolites. It's pretty clear that people pooped in their house. And I've been asked that. Why in the world would anybody poop in their house? Well, there are times when you don't want to go outside. And if you think about it, the children don't have diapers on. I mean, they are just going to do what they're going to do where they're going to do it. And so it led to unhealthy situations. We looked at these coprolites in the process of looking at the pollen, and we actually began to find worm eggs. So they were infected with worms, possibly even hookworm. So this is the assemblage that we found associated with all of this rabbit fur and all of the hair, the pronghorn. So the vast majority of it is retouched flakes, scrapers, and flake knives that would do the job, for processing these things. So what were they doing with this? A lot of cordage. We actually found 8 of these knots down in the lower right-hand side. This is not really cordage. It's just simply sagebrush bark that has been stripped and then tied together and then trimmed off. And that was the wonderful thing about people who just aren't real good about keeping the house clean. They just drop whatever it is that they're using where they leave it. And so we know that they were doing something with those. So this is a Mono California Paiute, about 1900. He's wearing a rabbit skin blanket. Inside the rabbit skin is a cordage that holds it all together. And so taking a look at the stone assemblage that we have and the remains of all the cordage and such, and those tied pieces of strips of sagebrush, I think that they were 12,000 years ago. They were doing exactly what this Paiute had done here and made a very warm blanket. That would be his blanket for sleeping in, as well as his coat during the day when it's extremely cold. So we just have an incredible assemblage of perishable artifacts. In other words, if you get out in the open and artifacts, you leave wood or leather or hair or something like that lying around, it doesn't take any time at all, and it's going to be gone. It's going to last maybe a year or two. Inside the cave, everything remains. This sinew is wrapped around this twig up here, this branch. We've got a wooden peg, clearly has been worked and brought to the site. A very delicate little bone needle. This last summer, in a similar age deposit, we actually found what appears to be part of a composite fish hook. In another site, the Conley Caves. So you would strap this needle to the end at an angle about like that, and a very effective fish hook, very similar to what the Klamath were using at the turn of the century. This shows you some of the artifacts from a half of a bucket of soil that we were screening. We've got burned bones, we've got our wooden peg, and this braided sagebrush rope, and obsidian. You'll notice it says 5.15 microns. So what we've done is obsidian hydration. Here you're looking at projectile points that have had a little slice of obsidian cut out of them. That's about 1 millimeter thick. We would take that, put it in epoxy on a slide, then grind it down until we can actually see through it under polarized light. And then we can read the number of, the amount of water that has actually penetrated the obsidian. So obsidian is just like modern glass. It actually will flow if you put it up long enough and just leave it alone. There are cathedrals where glass windows have begun to sag. And you can clearly see it, 1,000 or 2,000 years, and it actually begins to come down. So this is in the process of absorbing molecular water, and it, in the process, forms a rind. We can look at that rind under extreme magnification and take a reading on it. Then all we need to know is, well, how fast is that water getting in there? So once we can determine that, then we can estimate the length of time it has been since the Native American chipped out that artifact. It gives you the ability to actually provide a date on an individual artifact. Now, the problem is that temperature, soil, and soil chemistry and such can affect the rate that the water is actually absorbed, that the obsidian absorbs the water out of the atmosphere. So what we did was to look at one single obsidian source, Tucker Hill, which you can see there in the distance, is only about 20 miles away. And so we looked at that. 75% of all the obsidian in the bottom of the cave, the oldest component, comes from that single source. So that was a good one to focus on. Then we needed to understand temperature. So obviously, as things get buried, it gets cooler as they get deeper down. And so we set these tubes in the ground, and these little buttons here take a reading every hour for a whole year. So what we needed to do was be able to pull them out of the ground effectively and then download the information. We put them at 50-centimeter intervals from the bottom of the cave all the way to the top. Next. Well, we had 100 of those in, and This is the most sophisticated experiment relative to obsidian hydration that I'm aware of at this point. What we found was kind of a shock. There in the middle, you can see a large rock, kind of a grayish brown. That turns out to be kind of a solar sink. It has the highest temperature inside the cave. And guess where we found the majority of the chipping debris? Right around that boulder. So it's pretty clear that people, like that area, and that we were getting our best information there. So this shows you the results of that experiment. And the blue is obsidian, the black are radiocarbon dates. And so what we want to see are peaks that match each other and valleys that match each other. And so this is a pretty good evidence that indeed we're on the right track. It's not perfect. It's never going to be, for obvious reasons. Obsidian, an individual artifact, might start out, get buried for a while, and then some rodent brings it to the surface, or a person digs a hole for a fire, or some kind of a hole to store something in, and then it comes to the surface and it recycles. And so there are problems, but this is looking pretty darn good for us getting to be able to actually date each individual artifact. Next. Another way that we can look at things are, I have already mentioned this, the layer cake effect. The oldest artifacts should be at the bottom. All the debris should get younger with age, up near the top. And so when you're looking at these red lines that represent artifacts, man alive, you get down into the really oldest deposits, and you actually find the majority of the artifacts in the Paisley Caves. That's totally backwards. Ordinarily, the youngest material is where you're going to find the vast majority of artifacts, because there has been less time for the artifacts to be eroded away or buried or whatever. So good evidence that we've got excellent conditions at the Paisley Caves. Here I'm collecting a horse maxilla, the upper portion of the skull, in level 62. So we radiocarbon dated that, 13,625, almost, going on towards 14,000 years. Down below that, significantly, just 6 centimeters below it, we recovered a butcher cut rib. Now, how do I know that it was butcher cut? Well, we did some experiments. We actually went and bought some, pork ribs and made some stone tools and then made slices in them to see what kind of a pattern they resulted in. We ended up with 8 different characteristics that are not duplicated when somebody steps on a bone and then kicks back and perhaps causes the same kinds of scratches that people have said, oh, well, that's just a scratch caused by walking on the bones. They're perfectly straight. I've got feathered edges on them, parallel cuts frequently. This is indeed an artifact. And it's almost 14,000 years old, much older than Clovis. If maybe you don't know about Clovis, but those are the guys that were hunting elephants and camels and horses and such all over North America, and have been supposedly the first Americans. And so here we have evidence of people in the caves about 1,000 years before those guys ever even got started. Well, this was found in level 62 as well, in the same 1 meter by 1 meter square that we were excavating. I saw this, the woman was excavating, and I saw the rock begin to come out, and I said, keep your eye on that. You've got an artifact. It was just so totally different than everything around it. As it became exposed, you could see 3 different flake scars that had been knocked off the end of it, which is where you would break a bone if you were using it to batter something against the bedrock or another boulder. We did protein analysis, residue analysis on that surface, The laboratory that did the work said, oh my gosh, Dennis, when we put that in the solution, it reeked. It smelled like rotten flesh. And so they extracted mammoth or mastodon protein out of that surface, as well as Apiaceae and grass pollen, phytoliths, etc. of plants. So this one tool has been used for a variety of different activities. It kind of blows some of our, modeling out of the water, because we like to think, oh yeah, if you're hunting elephants and being really successful, you don't have to go to all the hard work, smashing your fingers and stuff, grinding up little tiny seeds. Well, I'm sorry, but I think they were interested in a nice balanced diet as well. As a matter of fact, you'd probably get awful tired of eating elephant if that's all you ate. Another thing is they didn't kill the elephant with this. We don't know that they killed an elephant at all. They may have found it dying or dead and just scavenged it. But why would they use a rock like this on an elephant carcass? Well, one of the things I point out to people is, when you were 25, 30 years old, you were getting pretty old in their society in most cases. And you begin to lose your teeth. There's no cleaning your teeth very well, and a lot of people lost teeth very early. So eventually, you need to be able to process dried flesh, and using a hand stone like this to soften it up, certainly one way that people, who had lost teeth could eat dried flesh, jerky basically. And so basically, there are good reasons why we might find mammoth or mastodon protein on it. In the same stratum, we found an obsidian flake nearby within about 2 meters that had been used also for cutting mammoth or mastodon. Now, how do I know that that's not contamination? We took soil samples from below that artifact, and we did the same tests on them. There was no mammoth or mastodon proteins in that. So I know that it's not contamination by an elephant coming into the cave and urinating on it, or meat breaking down from one dying there. This is my final cave, that I'm going to talk about tonight, cave number 5. It's where we found the oldest human coprolites. And so one of our major concerns that I've already talked about to a small degree is that people were saying that this site had been vandalized so horribly by people mining, actually effectively mining for artifacts and for fossil bones. So what we needed to do was test to see if indeed, if it had been churned up, then your dates are going to jump all over the place. If it has not been churned up, then they're going to be youngest at the top, and they're going to get progressively older as you go down. So what we did was to take a series of twigs at those where the papers are there. Each one of them is about 4 centimeters apart, and we ran radiocarbon dates. $800 a date, 130 dates. And what we found was that our youngest dates are at the top, 7803 up here, and at the bottom, 12,380. We learned an awful lot about that deposit. A lot of it, the radiocarbon dates tend to cluster in a band of age right at a certain point, and then they might be nicely stacked for a while, and then there might be another cluster where your dates are jumping around 100 or 200 years. It's pretty clear now that what we've got are rats that have been living in the cave for a long time. They build a big nest at the back of the cave, and there are cracks that they can escape in, and a bear comes along, or a badger, or something else, coyote, and rips the nest apart trying to get to those rats. Well, some of them escape, some of them get ate. But what happens, the ones that survive, they're right back the next night bringing all those twigs, all those branches back into the nest, rebuilding it, 1,500 pieces in a single night. And in a very short period of time, it's back up 1 meter high. We had to keep our garbage out of the site every night. If you didn't, you came back, it was everywhere, and it was in the nest. You know, your rubber gloves, your face mask, all the rest of it is constantly in the nest. I mean, they'll just steal you blind, as a matter of fact. They'll take your little line levels, your trowel, anything that you leave behind goes into their nest. So anyhow, what we think we have here is evidence of that process over and over. Some of those branches and stuff get buried. That's what you end up radiocarbon dating. Others get moved back into the nest, and it's just a process that has happened over the thousands of years. Quite honestly, we've got 270 radiocarbon dates now. You can do the math in your head if you want to. It's an obscene amount of money that has been spent just on dating. And the reason is, if we're going to try to change a paradigm that has been in American lore, archaeological lore, if you will, since the 1960s, that Clovis is first, then we've got to have unusual evidence, and that's what we have done. We know more about our site than anybody, as far as I can tell, than anybody else in North America. Certainly the number of radiocarbon dates outstrips everybody else. Anyhow, what we did, we were concerned about the fact that those rats have been peeing on everything. Now, there's carbon in there, you know, and it has to be contaminating your radiocarbon dates. So if you don't think about this, you're going to run a radiocarbon date, you'll get a date. If you like it, well, that's 10,000 years old. That's really cool. If you don't like it, then you might redate it or think about, well, what could be contaminating it? So we put this in distilled water, and the urine starts to come out. It mobilizes. And we pour it off, and then we do it again until it's absolutely clean of any extraneous carbon. So now we've eliminated the contaminations of the environment. Well, we actually took that. We wanted to know, how old is it? How old is that urine? And so we began the process of freeze-drying it. Here, as you can see, the flakes that are generated in the process. We radiocarbon dated those. And what we tended to find was that it was actually a little bit older than the twig itself. And so, well, why would that be? Well, because you're depositing that in an environment that is already in place. So there's already that contaminating carbon in the environment. And so, you know, we processed all of it. Up in the left-hand corner, you can see there's actually a rat pellet that has been cleaned, and that was in, you know, a human coprolite. And so, well, how in the world did that happen, you know? Well, you're living in this all the time. You know, you're preparing your food on the ground. The kids are running around. The dogs are running around. The dust is blowing. There are feathers in your food. You cannot keep it out. There's a lot of dirt in these coprolites, a lot of dirt. And people's teeth just got flat from chewing on grit all the time. And anything that goes in your mouth comes out, you know. So... yeah. So anyhow, what we found, though, here is that it was absolutely beautifully stratified, nicely laid down, youngest dates at the top, 8,000 over there, 14,000 down here at the bottom. You see that one that's in bright red there, 14,200? That's this item, and it's actually a protein profile says that it's a bare bone. There are no other identified bare bones in the Paisley Caves. You can see the sawtooth appearance. It's been kind of chewed up by Fido on the end over there. But this really looks, I mean, as soon as I saw it, I thought, man, that's an artifact. And then we actually got a radiocarbon date right off of the bone, 14,000 years. Now the question is that a natural product? I mean, if you leave a large bone like that out on the desert until it really gets brittle and dry, and then something heavy steps on it, like a cow or something, it'll actually snap and break and leave a sawtooth appearance, just like that in the left-hand corner up there, but you'll notice that those edges are all sharp. Those are 90-degree edges, so as that bone breaks, it just leaves a nice sharp edge. Here we've got beveled edges that suggest to me that this has been used quite a bit, and it has rounded off the edge. So it looks like a flesher that you would see in a buffalo jump, perhaps, on the plains. Another artifact that we have is another handstone. So these are cobbles that you would use to process food. I've got the circle around the polished area there. Our protein analysis gave us a hit for horse. Then we found a coprolite nearby within about 75 centimeters, just about 2 feet away. Same elevation. Got a date of 14,500 on it, and lots of Apiaceae pollens, which suggests perhaps some kind of our edible roots, like biscuit root here in the picture. This is the bone pit. Now, this is one of our cultural features. You can see a large upright slab. If you've done any yard work around, you know that slabs don't stand up on end by themselves. This one has been leaned up against this boulder here. Right behind it, we got into the bone pit. And we were working all summer long. This young lady in the upper left-hand corner here had kind of been in charge of getting this unit down. 6 weeks she had been digging, finding, I think, 1 flake of obsidian. And there was cordage and such in the upper portions of the deposit. We went through 80 centimeters without a single artifact. It was just barren, almost no bone. And then suddenly it begins to pick up a little bit. And then she came on a nice flat slab about that big. And she said, "Can I remove that?" And I said, "Oh, wait a minute. We don't know what's under it. So, we've got all the time in the world. We're not finding an awful lot, so let's just dig around it. We'll pedestal it, leave it on a nice little pedestal, and then see if anything else shows up." So we did that. We spent about an hour working together, showed her how to map the whole thing. She goes, "Can I remove it?" And I said, "Yes." And I walked over, got on the ladder. It was almost 2 meters down there, so like 6 feet up. I got out, started to walk away, and all of a sudden I heard, "Dr. Jenkins!" And it was electric. I mean, people jumped out of their holes instantly because you knew she had found something really cool. And she had hooked her trowel with the first swipe on this camelid thoracic vertebra. So we went through the whole process again. We were all excited. I mean, that was the weirdest looking vertebra I'd ever seen. I'm going, man, this looks like something from a pinniped or something at the coast, It's definitely not a cow. And so we worked all around it, and then she said, "Well, can I remove it?" I said, "Yes." And her partner there, Luann, was next up to excavate. So she got in, and I got out, started to walk away, sure that the excitement was over, and I heard, "Dr. Jenkins!" We came back there, and here is this part of a camel foot bone, and so astragalus. And so it turned out there was just a stack of bones of different animals in there. So we have horse hooves, we've got a mountain sheep jaw, which has, by the way, on the inside where you would cut the tongue out, there's actually a stone tool mark on that. It's 14,600 years old almost. Just incredible. And at the bottom of that pit, we found a coprolite. So this is 2002. A couple of years go by, and I get notified that somebody wants, Alan Cooper from Oxford wants to do DNA analysis on camels and horses. And he's heard that I've got them at the Paisley Caves. So he's a well-known geneticist. I didn't know that at first. I went to Idaho and looked at some other camel and horse bones, and they said, "Have you talked to Alan Cooper? He's getting samples." I said, "Yeah, I talked to him, but I don't know him from Adam. What in the world? He could lead me down a primrose path, and I'm not going to be taken down that path. And they, no, he's a great guy. He's world-renowned geneticist. And I said, okay. So I talked to him. He said, I'll send my postdoc, Eskavilerslav, and he'll take samples. I said, okay, well, send him in March 2004. I said, we're having the Northwest Anthropological Conference, and he can give a paper and explain it to us. And I thought, if this guy can't explain it, he's not getting my samples. It's just that simple. I don't care how far he's come, all the way from England. So what? I'm not giving him my samples. He came here, gave a talk, heavy Danish accent, but you can understand every word. He knocked our socks off. I mean, he was a great speaker. And when we were taking the samples later on that day, I was talking about what we had found in the caves, and I mentioned coprolites. He goes, you've got coprolites? I said, yeah. He goes, well, Cooper does the animals, but I really like coprolites. I'm going, whoa! I do DNA analysis on it, and I go, and you're kidding. He goes, no, it preserves really well, remarkably well. So I said, well, okay, and he took 14 back with him. So about a year later, 2005, I think it was about November. I remember it was getting late in the day for me, and it was really late in Copenhagen, and I get a phone call. And he goes, Dennis, how old did you say those coprolites are? I said, well, they're all different ages, but one of them came out of a pit that's 14,000 years old. He goes, we're getting Native American DNA out of them. I said, wait a minute, how do you know it's Native American? He goes, well, there's basically five haplogroups, A, B, C, D, and X in the Americas. You've got haplogroups A and B. And I said, whoa. Now, the other problem, Eska? We didn't do anything to protect it. So we know for a fact it's contaminated because nobody wanted to touch it with your fingers, but you're touching them with your gloves, and you're pulling those gloves on, putting them on, pulling them off all day long. And so they're just saturated with our DNA. He goes, yeah, they are. They're contaminated. But we can deal with that. We can filter it out with electronics, and the big chunks are the modern DNA that's breaking down. The smaller chunks are way smaller, and they get caught basically in this net. So we can sort out the modern from the new. So we got that process started. And here's what I've been talking about. This is Mount St. Helens. I've heard, I wasn't up here in 1980, but I've heard that white ash was literally everywhere, that you could not keep it out of your house. It was in your car. It was in everything. That's the way DNA is. If I had enough money, I could tell that every one of you were in this room tonight. Now, that would not be effective. It'd probably be a lot easier to track you some other way, but you're breathing, and in that process, you're leaving little sparklets of water, and in that water is your DNA. And that's the problem that you have when you're trying to collect items and keep them clean. I sit and watch CSI at night, and my wife says, shut up. I'm going, they can't do that. He contaminated that. They can't do that. and she's going, I don't want to hear it, man. You're ruining the story. So we have to do something about it. And what we have resolved to do was protect it the best way we could. It's not perfect. There is some contamination, but we really restricted it a lot once we began to get dressed for the job. They tell you to dress for a job when you go for an interview. That's what we're doing. So you're working away with your trowel, and you see the coprolite start to take form, and people say, well, what does it look like? Well, it looks like Fido stuff that has been out there all summer. It's just a little thing, and it's usually kind of hard, and it's, it's pretty exciting when you're looking for them. We've got about 1,800 of them, so, but it's an expensive process. The suits, are $30 a piece. And, the mask and everything else, you use it one time and you throw it away. And if you're green, I'm sorry, but it just kind of freaks you out, because at the end of the day, you have a big bag of garbage. But we have stopped the contamination a lot. So everything goes into the little cup here. This is a sample cup. You might recognize that from going to see the doctor, and they ask you for a urine analysis. And so it's sterilized. And what I learned real quick was, if it says sterile or it says scientific, it means expensive. And so you've got your throwaway little tweezers that you pick them up with, because you can't touch them. Even though we have 2 pairs of gloves on, we don't handle things. You touch something, and it's on a surface that has somebody's DNA on it, and then you touch something else, and it's just incredible. I remember the first time we suited up to do this, because you got to remember, I didn't know anything about it. It was like comedy capers. I mean, I helped the person myself, and I'm watching him get dressed, and he's trying to be really careful, and I said, "Oh, man, you just contaminated." "No, I didn't." I said, "Yes, you did. You touched that, and then you took it and you touched that over there." So we've actually got a 2-page analysis now that tells you step by step what each person does, what your assistant does, what you do, in what order, and we have stopped a lot of the contamination. And so then it goes into the tube, and we seal it up and write all the information, the address, where that thing came from, and then if it gets selected, it goes directly to the lab, and we never open it again. If it arrives in Copenhagen, and one time we had one that had been opened by security, concerned about the geological samples that we were sending, and so we just threw it away. But generally, they arrive without being questioned. And then they do the analysis, and what we found are haplogroups A2 and B2, which were common in Siberia during the Pleistocene. Next. So we've been telling people the truth. That's indeed where Native Americans came from. We had excavated the whole north end up there early on, and then the south end, and we had a meeting in 2009. I brought 16 experts from all over America to view the Paisley Caves. They asked me to dig this trench, and I really didn't want to do it, because I thought, man alive, we're just doing what Cressman did. We're digging and digging and digging. We need to get some answers to the questions. But it was only 3 meters, and so I said, okay, I'll do it, and I'm glad that I did. We opened up, and we found these beautifully laminated deposits, really hard. I mean, that's like cement. A student would get in one of these 1x1s, and they might work all day and get 5 centimeters in a day. Just watching them makes your fingers hurt. Just watch, ching, 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 and just a little bit of dust coming up every time, and you're going hours and hours and hours to watch them do that, and you can't feel sorry for them, though, because you got to keep moving. Well, we got down through it. You can see all of that's been dug up above, but that stopped the shovels. I mean, it was hard enough. They didn't want to dig down through it. So, I mean, this is so hard. Next, we called it rat doby. I mean, basically, it's just cement, and we cleaned it up and got on down into the softer deposits down below. We came out on this, like I said, a soft deposit, nice and organic, lots of rat pellets and twigs and stuff. And then we exposed another one of those mud lenses. I go, I recognize that from cave number 2. So this is sealing in anything below it. This is our fragile mud lens. And so I told the guy, I said, let's sweep it off. We'll take a picture. And he was cleaning it off and fell into this rat nest. So it was actually a marmot hole, probably. And I said, well, clean it off. Let's get pictures of the process, and we'll just go ahead and we'll start all over again. I was so glad that I did. He started to cut into the deposit and came on this projectile point, the only one that we had found in situ, or in place at that point. And we ran radiocarbon dates every 4 centimeters down through past that deposit. This is the best dated western stem projectile point in the United States. It's right at Clovis times, right about 13,000 years ago. we went right on down, taking that mud lens out. You can see it up in the upper right-hand corner there, and we exposed this large rounded boulder. So that's rounded off because it's been in the water with the waves going back and forth over it. But you can see that after it was rounded off, it has just been hammered. Somebody has used that as an anvil, has been battering it, and it's older than 13,000 years ago. Here's the, the east wall of our excavation. We decided to do obsidian hydration analysis. We ran, like I said, every 4 centimeters, we ran our radiocarbon dates. You can just see that they're nicely stacked up right down to about 14,600 years. Significantly, that's when we have the mountain sheep jaw that has, clearly had the tongue cut out of it and the cut on it. But looking at the obsidian hydration, I've been doing this since 1981, and I have never seen such perfect obsidian hydration results. 5.9, 6, 6.1, and then at the bottom 6.4, something really, really old down there. So our obsidian hydration is working. We recovered another projectile point, not very far away, actually about 1.5 meters away. You can see where the red triangle is. So these are 2 different views. One of them is the wall, looking up like this, and the other one is from the ceiling of the looking down. And the numbers represent different elements of animals like camels and horses and such that we have dated. So the significance of that projectile point is that we had a human coprolite we had dated in, I think, 2004 at about 12,000 years. I thought, well, that seems about right for level 40. And so then years went by and we redated it. And it came back 10,965. 1,000 years difference in those 2 radiocarbon dates. Whoa. So who's right? We ran 10 more radiocarbon dates, $800 a piece, and we found that it gave us, that one bowel movement, gave us about 6 different clusters of ages in those 12 dates. It is undoubtedly 10,965 radiocarbon, so basically almost 13,000 years. But we are really learning a lot about the process of radiocarbon dating and what coprolites will give to you. What raises the hair on the back of my neck as a scientist, I'm going, I thought we were being objective. And what I'm finding out is that the results sometimes come back and it's up to you to decide whether you like it or not. And I've seen multiple times where people didn't like a radiocarbon date and they explained it away. They didn't have evidence. They just simply explained it away. And that, I hope, changed my perspective about science. Anyhow, so we began to run some dates on horses, equus phalange, basically a toe bone, and got this date here at level 43. Clear down at the bottom, we had a human coprolite that was, dated at about 14,000 years. And so I was thinking, man alive, that's getting, way up there. I would have expected it to be younger. And so I began to run radiocarbon dates, and got nice stack. 8 dates I ran down through there, and they're just nicely stacked. And then I got down to and I was really excited, got down to the bottom and sent off a soil sample. I picked out these little tiny twigs out of a soil sample that was taken by a student. And then I ran a sage grouse bone as well. Those 2 came back at 12,000. So this projectile point has come out of 14 to 15,000 year old deposits, but we've got the possibility that that point is out of place because we have young radiocarbon dates. And I know you think that 12,000 is pretty old, but I'm kind of jaded. And if it's not 14,000, it's not really old, So how do I test for that? Well, we go back to obsidian hydration. So we know where 6.1 is. We know where 6 microns are. And so what we looked at was, well, what's its source? Is it Tucker Hill source, and what is its hydration. Indeed, that indicated that that artifact is at least 13,500 years old. So I believe that the point is where it belonged, that it is indeed 14 to 15,000 years. I have not proven that, but that's certainly what I'm leaning towards. These are all radiocarbon dates that should be in the Clovis age range and older. And I note the fact there is no Clovis technology at all. So we don't have any of the debitage, the overshot flakes, or bone rods and things that we expect in our typical Clovis technology. So what were people eating? Well, what I've shown you is that they're eating a lot of different things. A very healthy diet, a good broad range. You know, as far as we can tell, they were eating elephants. They were certainly eating deer, mountain sheep, as well as pronghorn and rabbit, as to the earliest time periods. They're taking also plants, lots of grasses show up, pollen on tools and such, and a lot of lomatiums, probably like biscuit root that you see here. One indeed did have a lot of bison hair, as well as bison protein, as well as human hair. It had at least one hair that appeared to be human in it. We got a hit for human protein in that coprolite as well. Horse protein. So, you know, people are definitely, you know, hunting or, as far as we can tell, processing animals that have been extinct for thousands of years in America, as well as our mammoth or mastodon protein. And our extant animals that are out there today, that continued right on up through time, of course. And like I said, the botanical lens has just composed a lot of rabbit as well as pronghorn. So, conclusions, I know, finally. Our Paleo-Americans were in the caves at least by 14,500 years ago. These are not, in my opinion, the first people. This is just simply where the evidence and the scientists have met each other in the Paisley Caves, all right? I think that the evidence, you know, we've seen in the food, knowing, you know, where to find those roots, knowing when to find them, all suggest to me that people are well adapted to this environment already. They've been here for some period of time. We don't know how long, but I'm hoping that at any time an older site will be found right here in Oregon or somewhere in the West, and it'll help verify the Paisley Caves. They were broad-range foragers. They ate lots of different kinds of food, a very healthy diet as far as I can tell, and their earliest technology appears to be what we call Western stemmed, and these are not Clovis artifacts. That suggests there were two populations at least with different technologies on the landscape and in North America at the same time, and there could very well have been several more. So thank you very much. All right, so if we can get the lights back up, I'll take a few, actually, I'll take a lot of questions if you've got them. Yes? What does coprolite? What is a coprolite bone? Bone? Yeah, I saw in one of your pictures. Yeah. There are bones in the coprolites. Actually, humans, I spit out anything hard. I got to tell you, if I chomp down on something, I really don't like it. But the Paiutes in Nevada would dry a rabbit and crunch up the entire thing with hammerstones and then eat the bones and all. And on the Northwest coast, they don't pick the bones out of the salmon. They grind them up too and cook them until they could eat them in many cases. So, very different things. So we commonly find rabbit bones in what appear, and all the evidence suggests are human coprolites. Good question.
How did they get here?
How did people get here? I've got to tell you, I lean towards the boats. It seems to me that it would be the easiest way to get here. I think a lot of people think about the distance. It's too far, how are you going to get, onto land periodically and things like that. But it's pretty clear to me that we really don't know that much about the glaciers and what they were doing along the coast. There were refugium, is what I'm getting to, places where there were plants and animals and they could land periodically, as well as the fact that I got to tell you, humans are resilient. We, if there's any place that you think we haven't been, there's been somebody there, and that may have been very early. I think I just can't see any reason why they wouldn't have been here very early. Well, we're looking at probably 400 feet. What we're starting to find out is that there are places along the coast that never went down under the water, even though, in other words, the water is rising as the glaciers are retreating. The water is coming back up, right? There are places where the rebound, because the weight is being lifted off of the continental shelf, and so the rebound was as faster than the water. Actually, there are islands in Canada. I visited one in April, and it stayed well above the water, and it's today substantially out of the water. And guess what? They're finding artifacts that are 14,000 years old. So I think that we're going to find out here pretty quick that things could change virtually overnight. It's only going to take publication of one very unique site, and we're going to go, well, what was all that arguing about? Okay, thank you. Anything else? Anybody else? And I'll be here for a while, so thank you very much.